Hi, welcome back to Math 111. We're going to talk about section 3.2, and this is going to build on the polynomial work that we did already. What we're going to do is we're going to talk about the factor theorem and the remainder theorem, and these are two really important things that will help us in our efforts to find the zeros of polynomials. So let's suppose we want to solve this equation. We've got this polynomial f of x equals x to the third plus 4x squared minus 5x minus 14. And we want to find the zeros, and we think, all right, piece of cake, we're going to graph that puppy. So we throw it in our calculator or on Desmos, and we graph it. And sure enough, we find that x equals 2 is 0. But when we try to find these others, we get not nice answers. So now what do? We know what we kind of need to do. We probably need to use the quadratic formula or something else because these are real numbers, but they're clearly not. They might not be rational numbers. They might be fractions that we don't recognize, or they could be square roots. Chances are they're going to be square roots, but regardless, we need to figure this out. So here's what we do. We know that if 2 is a 0, that means that x minus 2 is a factor of the polynomial. So that means we can write our x to the third plus 4x squared plus 5x minus 14 as x minus 2 times some other polynomial. How do we find that polynomial? Well, we've got a hint. We find that polynomial through division. So yes, our good friend polynomial division is back. And here's how we do that. So I'm gonna show you an alternative to long division in a minute, but let's start with long division. So we set this up as x minus 2 goes into x to the third plus 4x squared minus 5x minus 14. And what we're gonna do is we compare x to the third and x. And we ask ourselves, what do I need to multiply x by in order to get x to the third? And the answer is, of course, x squared. So now I take this x squared and I multiply it all the way through my x minus 2. And I put that answer right here below what I started with. And I have x squared times x is x to the third, minus 2 times x is minus 2x squared. And you're thinking, but that's not what you have written here. You're right. That's because the next step is to remember that we need to subtract, because that's what we do in long division. But we kind of suck at subtraction. So we're going to change our sign so we can just add the opposite. So I changed my signs through here and added down, and I get 6x squared minus 5x. And now, guys, we just wash, rinse, and repeat. So we look at 6x squared and x, and what do I need to multiply x by in order to get 6x squared? 6x. Take my 6x, multiply it all the way through my x minus 2, and I get 6x squared minus 12x. Reverse these signs and then add, and I get 7x minus 14. What do I need to multiply 7 by in order to, what do I need to multiply x by in order to get 7x? 7, take my 7 and multiply all the way through, and I get 7x minus 14. Reverse the signs and add, and I get a remainder of 0. Now, this remainder of 0 turns out to be pretty important because it means a lot of different things. One thing it means is that x minus 2, this thing that we were dividing by, is a factor. So the fact that the remainder is 0 means that x minus 2 is a factor of my polynomial I was dividing into. It also means that 2 is a 0 of this polynomial. That also means that my original polynomial can be written as x minus 2 times whatever I have left up here, x squared plus 6x plus 7. Which means I can find my other zeros. I already know 1. I already know that x equals 2 is a 0. And but I have to find these zeros. So I can find these zeros by using the quadratic formula. So x equals negative 6 plus or minus the square root of 6 squared minus 4 times 1 times 7. Or negative 6 plus or minus the square root of 36 minus 28 over 2. 36 minus 28 is, give me a second. I'm not trusting my ability to subtract today. 36 minus 28 is 8. So this is negative 6 plus or minus the square root of 8 over 2. Square root of 8 can simplify as 2 square root 2. So this is going to be 3 plus or minus the square root of 2. So my zeros are 2, 3 plus the square root of 2, and 3 minus the square root of 2. Okay? All right, so that's really the crux of what we're going to learn in this section. But I want to show you a different way to divide. This is called synthetic division. And your textbook has got a whole big discussion that you should read. Synthetic division is fun and it's cute and it's powerful, but there are some things you have to be aware of. We can only do this if we are dividing by x minus some number. In this case, x minus 2. As long as we're dividing by x minus 2, we're going to use the fact that if we look really carefully here, we can see that the coefficients kind of fall down, right? And there's a pattern that develops. And I'm not going to worry about developing the pattern for you. What I'm going to do is show you how to do synthetic division. So to do synthetic division, we first have to be dividing by x minus some number. If you're working with x plus something, you want to rewrite that as x minus a negative of that number. If you're working with something like 2x plus 7, then what you want to do is you want to rewrite that as 2 times x minus a negative 7/2. Okay? Regardless, when we do our synthetic division, the number you're going to use is going to be the number that is subtracted from the x. So I'm going to erase some stuff that I don't need anymore. I'm going to erase all of this. And here's what we do. We start, so what we're doing is we are simplifying x to the third plus 4x squared minus 5x minus 14 divided by x minus 2. We take the coefficients of our numerator, just the coefficients, the 1, the 4, the negative 5, and the negative 14 now. Here's what we need to realize. If we start with an x to the third, then I need to have a number as a coefficient for x squared, and a number for a coefficient of x, and a constant term. If any of these are missing, you need to put in a placeholder of 0. Okay. Then next to that line, we put a box. And in that box goes the number that we are subtracting from x. Notice I did not put in -2. I put down 2. Okay. Here's what we do. We start by dropping the leading coefficient straight down. Now, I'm going to take my 2 and I multiply it by the 1. And that number goes right here. So that'll be 2. And now I add them together. And I get 6. Notice over here when we did our long division, we had a 4 plus 2 equals 6. This 4 plus 2 equals 6 is the equivalent of this same set of operations from our long division. Notice also that number showed up here. All right, now we do this again. We take the 2, we multiply it by the 6, and that number goes underneath the next number in line. 2 times 6 is 12. -5 plus 12 is 7. So again, we are adding. And again, notice, -5 plus 12 is 7 shows up in our long division, and the 7 showed up in our answer. Take the 2, multiply it by the 7, put the result under the next number in line, and add, and we get a remainder of 0. Just like we did with long division. This guy will always be the remainder. Okay? So what's all this mean? Well, these are the coefficients of our quotient, and our quotient is the result of the subtraction. So in this first column, we started with an x to the third. The degree is reduced by 1. We started with an x squared, that becomes an x, and this is now my constant term. So what this means is that my division, my x to the third plus 4x squared minus 5x minus 14. I was dividing out the factor I knew, that was x minus 2, and I got x squared plus 6x plus 7. Okay, if you're struggling with synthetic division, think about it for a while, read the textbook, starting at the beginning of section 3.3, or 3.2, which is on page 257. So page 257 is really talking through this example that I just worked. Bring any questions that you have to class or to the next time we get together in person or to a study session. So the bottom line was we were able to find the other zeros. I use this as an example to illustrate and remind you of synthetic division, because we're going to use synthetic division a lot for the remainder of this chapter. Okay, I told you we were going to use, so I didn't spell out the remainder theorem in words, but here's what it amounts to. If we take some polynomial and we rewrite that as another polynomial, so this is really doing the division. Q of x is the quotient, d of x is the divisor. So in this example, this guy is p of x. This guy would be d of x. And this guy would be q of x. We would get out some remainder. Now, so if we are dividing, if this guy is something like an x minus a, then it turns out that this remainder is the functional value of this number. Now we care about that because it means that if my remainder is 0, then this a is a 0. And that's the primary use for this. But this is, if you like to do synthetic division, this is one way to find the functional value of a number. Most of us are going to plug it into our calculators, but synthetic division is pretty simple. So the reason we care about that is because if we do that division and we get a 0 for the remainder, that means that that number that we were subtracting from C is a 0 of this polynomial, and that means that x minus that number is a factor of the polynomial. That's really all the factor theorem says. So let's practice our synthetic division. Let's start with the top one. We're going to take 5x to the third minus 2x squared plus 1, and we're going to divide by x minus 3. So 5x to the third minus 2x squared plus 1 divided by x minus 3. Okay, start with we're dividing by x minus a number, so that number goes in the box. Now we're going to start listing our polynomial coefficients, but we're going to be a little careful. We're starting with an x to the third, so that's 5x to the third minus 2x squared plus 0x plus 1. So I don't have an x, but I put a placeholder in there. So this 0 takes the place of the missing x term in my polynomial. Make a line, drop the 5 down, multiply 3 times 5 to get 15. Add -2 and 5, and we get 13. 3 times 13 is, 39. Add 39 to 0, we get 39. 3 times 39 is 117. Add, and we get 118. This means that this division is equal to 5x squared plus 13x plus 39. Remember, this guy is my remainder, plus 18 over x minus 3. Whoops, 118. Practically speaking, what this means is that 3 is not a 0 of this polynomial. It also means that x minus 3 is not a factor. And it means that if I put 3 into that polynomial, so if I put 3 in, 5 times 3 to the third power, minus 2 times 3 squared plus 1, I'm going to get out 118. Am I? 5 times 20, yeah, I would believe that. Okay? All right. Let's do another one. X to the third plus 8 divided by x plus 2. Okay, again, we're going to rewrite our x to the third as x, or our polynomial as x to the third plus 0x squared plus 0x plus 8. We're dividing by x plus 2, but I need that to be x minus some number. So instead of plus 2, I'm going to write minus a negative 2. So now I can put my negative 2 in my box. Write down the coefficients of my polynomial. And do my synthetic division. Drop down the 1, multiply negative 2 times 1, we get negative 2, and add negative 2. Negative 2 times negative 2 is 4, plus 0 is 4. Negative 2 times 4 is negative 8. Add them together, and we get a remainder of 0. That means this division is equal to x squared minus 2x plus 4, which if you remember the formula to factor a difference of perfect cubes, you would have known. But what that means is that x plus 2 is a factor of x to the third plus 8, and that if we plugged in negative 2 to x to the third plus 8, we would get 0, which is true. Yeah? All right. Let's do the last one. And I'm actually going to clear my slide for this one. What have we got? We've got, all right, we'll write it down just like this. So 4 minus 8x minus 12x squared. 4 minus 8x minus 12x squared divided by 2 times x minus 3. There's a lot of stuff going on here that we have to address. The first thing we want to do is write our polynomial on top in standard order. So we're going to rewrite this as negative 12x squared minus 8x minus 8, or sorry, minus 4. Now, remember that when I do my synthetic division, I need x minus some number. So I factored out the 2. So what I'm going to do is I'm going to put in my minus 3/2, except it's not going to be minus because it's going to go in the box. And my coefficients are minus 12, negative 8, and negative 4. Okay. Negative 12 times 3/2, that's negative 36 divided by 2 is going to be negative 18. Whoops, sorry, that's not what happens first. What happens first? We drop down the leading coefficient. So I drop my leading coefficient down. Now I take negative 12 times 3/2. Negative 12 times 3 is 16, or sorry, negative 36. Divided by 2 gives me a negative 18. Add negative 8 to negative 18, and we get negative 26. Negative 26 times 3/2 is negative 39. Add those together and we get, add negative 39 and negative 4, and we get negative 43. So we have to be a little careful here, because what we did was we divided just by the x minus 3/2. So what we've really done is not address this 2 yet, right? So what we've said is that negative 12x squared minus 8x minus 4 can be rewritten as 2 times x minus 3/2 times negative 12x minus 26 but I've got a remainder, so that's going to be minus. Okay, let's do this a little different. So what I've got over there in my synthetic division is that negative 12x minus 8x minus 4 divided by x minus 3/2 is equal to negative 12x minus 26 minus 43 over x minus 3/2. I haven't addressed the 2 yet, but I can put that in as long as I put it everywhere. So that means that my division, my 4 minus 8x minus 12x squared divided by 2x minus 3 is going to equal negative 6x minus 13 minus 43 over 2x minus 3. This is the same thing I would get if I did the long division. All right, practice that. Make sure it makes sense to you. This last one is probably the trickiest case, and we can use long division for this if we really want to. All right, remember multiplicity. We talked about multiplicity. It comes from the exponent that is on the factor that generates the root. And here's the deal. We care about that because, roughly speaking, a zero can be divided, the factor associated with a zero of a function that's got a certain multiplicity can be divided into that polynomial as many times as is that multiplicity. So in other words, if I've got a 0 with multiplicity 2, then I can take the factor that's associated with that 0 and divide it twice into that polynomial. Let's work an example. Let's say we know that x equals 1/2 is a 0 with multiplicity 2 for the polynomial 4x to the 4th minus 4x to the 3rd minus 11x squared minus 12x minus 3. Okay, so 4x to the 4th minus 4x to the 3rd minus 11x squared plus 12x minus 3. And we've been told that x equals 1/2 is a 0 with multiplicity of 2. What that means is that x minus 1/2 squared times something else will not have a remainder. So we could write this thing as x minus 1/2 squared times something else. In order to figure out this something else, we divide x minus 1/2 into this polynomial twice. So I'm going to use synthetic division to divide my 1/2 into 4x to the 4th minus 4x to the 3rd minus 11x squared plus 12 minus 3. Drop down the 4. 4 times 1/2 is 2. Add those together. 1/2 times negative 2 is negative 1 plus negative 11 gives me negative 12. 1/2 times negative 12 is negative 6. 12 minus plus negative 6 is 6. 1/2 times 6 is 3, and sure enough, I get a remainder of 0. Okay, what I've just done is rewritten my polynomial as x minus 1/2 times 4x to the 3rd minus 2x squared minus 12x plus 6. But I know that there's another factor of x minus 1/2 hiding in here. So I'm going to take my 1/2 and divide into this polynomial. So drop down the 4. 1/2 times 4 is 2. Negative 2 plus 2 is 0. It's a 0. That'll bring down my negative 12. 1/2 times negative 12 is negative 6, which gives me the remainder of 0, which proves that my 1/2 does indeed have a multiplicity of 2. So my polynomial now is x minus 1/2 from the first division times x minus 1/2 from this division times 4x squared minus 12. And if we want to find all the zeros of this polynomial, we're there. Because now we've got x minus 1/2 squared times, let's factor out that 4. X squared minus 3 equals 0, which means that x equals 1/2 twice. So we've got zeros of x equals 1/2 with a multiplicity of 2. And we could solve this and come to x equals positive and negative square root of 3. So these are my zeros, 1/2 and positive and negative square root 3. Okay? This repeated synthetic division is going to become your friend as we move through this chapter. So let's talk about how it all comes together. If I've got some polynomial that's not a constant, which means it's at least linear, the following statements all mean the same thing. If c is a 0 of that polynomial, then if I plug in c, so p of c, I will get 0. It also means that c is a solution to the equation where that polynomial equals 0. It also means that x minus that number is a factor of my polynomial. And that if we graph this polynomial, the point C0 is an x-intercept. These interconnections are really important for you to understand. So make sure that that makes sense to you and bring any questions that you have to me when we get together again. I will talk to you all soon.